Welcome. In this section, I'm going to be covering 1.5, and the objective here is identifying invalid arguments. So let's remember, logic is the science that evaluates arguments. Let's also remember that we have two types of arguments, two general kinds of arguments. One is deductive arguments, and the other is inductive arguments. So in this section 1.5, we're going to be focusing in on deductive arguments. Now, we also know that deductive arguments are either valid or invalid, and we're going to be trying to develop a method to distinguish invalid arguments from valid arguments. So what is a valid argument? So a valid argument is an argument that has a special kind of form, okay? The structure of the argument. It has to do with the structure of the argument. It does not have to do with the truth or falsity of the premises and conclusion. And this is one of the most difficult things for students to understand. Let me give you an example. Here's an example of a valid argument. All A are B, all C are A, all C are B. Now, A, B, and C can stand for anything you want it to stand for. It doesn't matter. It's always going to be valid because the form doesn't change. So for instance, if I say all mammals are animals, I'm substituting A for mammals and B for animals, and I say that all cats, C for cats, and A for mammals, I say all cats are mammals, I have produced two true premises. And I can also then say, since I have two true premises, the conclusion is a valid form. The conclusion must be true. And you will see that the premises entail the conclusion. So if all mammals in the universe are animals and all cats are mammals, then it has to be the case that all cats have to be animals, right? It follows necessarily. It's logically impossible for premise 1 and 2 to be true and 3 to be false. Why? Because it's a valid form. The form, the way it's structured, is valid. Now, I could easily say all dogs are cats, or let me substitute A for animals and B for birds. All animals are birds. All cats are animals. Therefore, all cats are birds. This is false because the first premise is false. All animals are not birds. But the form hasn't changed. And you have a false premise and a false conclusion. The argument is still valid. You see, the argument, the premise is the form of the structure of the argument has not changed. I can substitute anything I want for it. All elephants are mosquitoes. All cats are elephants. Therefore, all cats are mosquitoes. This is false. All false. Completely false. I just make up anything I want. I have not changed the structure. The structure stays the same. Therefore, the argument remains valid. It is an unsound argument because the premises are false. I hope this makes sense. Now, how do I know that an argument is invalid? Well, what we are doing here is we're creating a substitution instance. When we've given you all these examples here, what I'm doing is I'm substituting a category of things for each of the variables. So for instance, all A or B, in this example, all sporting events are engaging pastimes. I'm substituting sporting events for A, and I'm substituting engaging pastimes for B. All baseball games for C are sporting events. which is A. All baseball games are engaging pastimes. So this is what we mean by a substitution instance. In this case, we have a valid argument. Now, here's how you develop a counterexample to demonstrate that an argument is invalid. This is called the counterexample method. There are very simple 2 steps. I'm given an argument and I isolate the form. How do I do that? I just do this. I say all migratory waterfowl are birds that fly south for the winter. I need to use a variable to substitute for each of these categories. So you could take migratory waterfowl, and you could use any variable. You can use A, you can use M for migratory waterfowl. It doesn't matter as long as you're consistent. So you can say all A are birds that fly south for the winter. We'll say B, all A are B. All geese are migratory waterfowl. So all C, we'll say C for geese, are migratory waterfowl, and we used A for that. So therefore, all geese, all C's, are birds that fly south for the winter, and we used B for that. So we have this. We construct this form. All A are B, all C are A, all C are B. Now, the second step is you have to determine if an argument is invalid. What you need to do is, once you've got it in form, let's take this form for instance, all A are B, all C are B, all A are B. You have to be creative here. You have to come up with examples. That's why we call it a counterexample. An example in which the 2 premises are true, but the conclusion is false. If you can do that, just one example, then you've demonstrated that the argument is invalid. I hope this makes sense. So let me give you an example. So all dogs are animals. This is true. All dogs are animals. 2, all cats are animals. That's also true. All cats are animals. 3, all dogs are cats. That's false. That is a good example in which a substitution instance in which the premises both are true and the conclusion is false. I have demonstrated through that counterexample that this argument form is invalid. Why? Because a valid argument form is such that if the premises are true, then the conclusion has to be true. It must be true, necessarily true. And I just gave you an example in which both are obviously true, premise 1 and 2, and the conclusion is false, and therefore the argument is invalid. I hope that this lecture has helped you understand the meaning of validity and invalidity of deductive arguments. Thank you.